So hello guys, welcome back to Gettobyte YouTube channel. In our last video, we have delved into the different embedded security mechanisms so as to safeguard our embedded products, whether those of automotive ECUs, smart meters, drones, or any other embedded product. Now in this video, we are gonna delve into the different cryptography primitives that are the foundational blocks for these security mechanisms and as well as for cybersecurity standards like of ISA 262, EAS 189, DLMS/COSM smart metering cybersecurity standards or any other cybersecurity standards for of any products. And these cryptography primitives are core mathematical algorithms, mathematical functions which plays a very important role in our even networking protocols like of TLS SSL, Mbed TLS, MAC OSEC and all these. And we are going to delve into these cryptography primitives from the perspective of use case and application from an embedded software design point of view in terms of what parameters we need to send so as to encrypt or decrypt via different cryptography ciphers, how to use those cryptography ciphers, what are the exact use cases and applications in with respect to the different scenarios of an real-time embedded products and the situations. So this video and this understanding will be totally from an application high and use case perspective so that one can get to know which cryptography ciphers to use so as to safeguard our embedded products from what kind of cyber attacks or from what or to protect them from which kind of situations. So now without wasting time, let's get started. There are three major categories of cryptography primitives that are used across all different embedded products, cybersecurity standards, or networking protocols. And these three categories are: first is symmetric cryptography ciphers, second is the asymmetric cryptography ciphers, and then comes the hashing cryptography ciphers. You take any cryptography standard or cybersecurity, the cryptography algorithms which are used in these core standards or protocols will be falling in one of these three categories. Now let's delve into these three categories one by one. First one is the symmetric algorithms or the symmetric ciphers. As its name says, symmetric. So for both encryption and decryption, symmetric. The same keys are used for encrypting a original message and also for decrypting the ciphertext after an encryption. And that's why it is called symmetric cryptography ciphers. One of the most widely used cryptographic symmetric cipher is the AES, Advanced Encryption Standard. And these symmetric algorithms are mainly used to secure the communication, like for exchanging the data between two embedded products in a secure way, so that not any intruder can get to know what an original message is. For secure communication mechanism, our symmetric algorithms or symmetric cipher is being used. And most common symmetric algorithm is the AES, and AES has different type of modes: CBC mode, ECB mode, CTR mode, OFB mode, or the GCM or XTS mode. We are going to dwell into each of these modes in this video in couple of minutes later. And for using the symmetric algorithms, there are mainly 3 or 4 parameters that are used depending upon the mode of the AES that we are using. First one is the original message, that is our original message that we want to securely transmit or receive. Then comes the key, the symmetric key, the secret key that will be used for encryption or decryption. And then third comes the either initialization vector or the nonces or the counter value, which are the extra parameters depending upon the mode of AES that we are using. And in terms of the decryption, the same parameters are used, just instead of the original message we are gonna send the ciphertext that needs to be converted into the original format. Then comes the second cryptographic primitive, the asymmetric cryptography algorithms or ciphers. As its name says, asymmetric, so it means for the encryption and for decryption different keys are used, and that's why it is called as asymmetric. Then there are two most widely asymmetric ciphers, RSA algorithm and the ECC algorithm. In this case we have two keys, private key and the public key. Public key will be available to all the people, it will be like globally, or like it will be broadcasted to all the receivers and all the people, and the private key will be only kept secret onto the main master device or the main authenticating device. So our original message is encrypted, or the original message gets encrypted via the private key. Now to decrypt the ciphertext, the generated encryption message, we will be needing a public key, and using the public key only we can get the original message back to us. So this is the working of an asymmetric ciphers, and asymmetric ciphers are most commonly used for device authentication techniques. As in this case, we have two keys, public key and a private key, and public key is universally broadcasted to all. So we can't use it for secure encryption, as public key will be available to all the receivers. But the person who is having the private key will only be able to can check whether the message receiving coming from an or transmitting is coming from an authentic user or not. So asymmetric ciphers are most widely used for device authentication techniques like digital signatures, digital certificate, shared key protocols. More on the asymmetric ciphers with the use case and usage, we are going to dwell into the next video. In this, we are going to dwell more in depth into the symmetric ciphers. Now, the third cryptography primitive is the hashing primitive. And in terms of the usage of asymmetric ciphers, during the encryption, we need a private key, we need a original message, and the number of bytes or the length of the data that has to be encrypted. And in terms of the decryption, we need a public key, the ciphertext that we needs to be decrypted, and number of bytes again of how much data it needs to be decrypted. And apart from this, depending upon the RSA or ECC, the extra parameters like of RSA type or the ECC curve nature would also be needed. That we will dwell more when we will dwell into the use case video of asymmetric ciphers. Hashing cryptography ciphers are the one-way mathematical functions or the algorithms that convert an input message into a fixed length hash value, and this fixed length hash value is irreversible. So hashing algorithms are most commonly used for integrity checks, for checking that whether the receiving data is not tampered with or it is not manipulated, because the hash value will be unique for every input message. So if someone has manipulated the input message, its hash value will also gets manipulated or changed. And most commonly hashing algorithms are the SHA-256, SHA-384, and SHA-518. Over here, 256, 384, and 518 are the SHA output size. That is the amount of output. Let's say the input message be of 16 bytes, 32 bytes, of any bytes, but how much hash value size that we want, we can decide according to the use of SHA-256. So it is going to generate the 256 bytes of hash value output, that is 32 bytes. In the case of 384, 512, correspondingly bits of output hash value we are going to get. And in terms of the usage of hashing algorithms, there is no key required. Only the original message or the data that whose hash output value has to be generated, and the type of SHA algorithm that we are going to use. Now, all these three cryptography ciphers, the hashing, symmetric, asymmetric, as briefed, are used for the different cybersecurity standards, cryptography or security protocols for securing our products from an hack proof and cyber attacks. Now, what we are going to do is dwell into the AES symmetric ciphers and the usage of different AES modes, which mode to be used in which particular secure communication mechanism, how to use them, what is the storyline with them, and that all we are going to understand from a perspective of an automotive example. In the next video, we are going to dwell into that use case of AES algorithm and the modes from an automotive use case. So till then, see you guys in the next video. Keep on watching the channel. If you like the video, do subscribe to the channel, mention down your views, and share it with the masses so as to spread the knowledge. And be curious to be skilled engineer and not just graduated one.